So first, let's talk about those pre-training workloads, those absolutely enormous workloads. So how do you size those workloads appropriately? We're going to introduce a rule of thumb called the 16x rule. Now, there's a myth out there that trained model sizes, the weights as you might load them into an inference engine, would be the amount of GPU memory you'd need to actually train a workload. That is wrong. It's wrong by an extraordinary amount, orders of magnitude, exponentially so. Generally, the way we look at this is we need 16 bytes of GPU memory for every parameter in a model. And that's given the situation with mixed precision and a standard atom optimizer. Let's break that down though, right? So you have the weights are actually only 2 bytes. Now on top of that, you have the gradients, right? So 2 bytes for those. Those are the signals that kind of tell the model how to improve. Then we have the optimizer states. And those literally take up the other 12 bytes. The way that's broken down, Atom keeps essentially a high precision copy of the weights and then plus 2 running statistics for every parameter, and those add up to your 16 bytes. Now, plus activations, which scale with batch size and sequence length, which can eventually actually exceed the trainable state required for the model, especially with long context workloads. The reality is stark, though. For a 7 billion parameter model, just to host the trainable state, right? So just the bare weights themselves, you're talking about 60 gigs. An H100 GPU has 80 gigs of GPU memory, so that only gives you a maybe 20 gig overhead for the trillions of tokens you're looking to train on top of that.